Now we're going to look at matrix equations and systems of linear equations. We're going to be using matrix inverses to solve systems of equations. So this is just another method of solving an equation. I've got some terminology, and a lot of it you've already been hit with. First thing is the coefficient matrix. Remember, those are the numbers that's with your variables. Also notice it's a square matrix. Your variable matrix. That's your variables that are being used, x sub 1, x sub 2, x sub 3, and x sub 4. It is a column matrix. And then your constant matrix, which also happens to be a column matrix, because first thing we're going to look at is a times x equals c. I'm going to copy this up here as if I was going to multiply it. Let me get this one up there. Now, if I multiply this first row times first column, it's going to give me first row, first column element. But if you multiply, I'm going to have 1 times x sub 1 plus 3 times x sub 2 minus 2 times x sub 3 minus 1 times x sub 4 equals 9. If you'll notice, that's my first equation. If I do the second row, first column, that will give me second row, first column element. So 2x sub 1 plus 4x sub 2 plus 0 plus 2x sub 4 equals 10. And we could find the other equations that way. So we're rewriting the equations into a matrix form. So let me get rid of these because I don't need them now. Variable matrix, constant matrix. Now, here's where it goes. We're going to multiply both sides of this equation, notice by A inverse. Notice where they are. It has to be at the front end on both sides. But now on this side, when I do A inverse times A, remember that gives me the identity matrix. And identity times whatever will give me my whatever right back. So this is my variable matrix equal this, which means I can solve this system of equations. Now it says solve the above system using matrix inverses, so I need you to go put in matrix A and matrix C. So pause me. I've already got mine in. I put matrix A in A and matrix C. I like C under constant. Okay? So now, here we go. This is the bottom line. I need A. Remember, I have to use the inverse key. And now let me go get matrix C. Hit enter. So remember, x sub 1, here's a column matrix. X sub 1 should be 0. X sub 2 will be 2. X sub 3 is negative 2. And x sub 4 is 1. That's it. It's very quick. Almost as quick as doing the RREF key. If matrix A does not have an inverse, then the given system either has no solution or an infinite number of solutions. And the only way then that we could work the problem is by going back and doing the Gauss-Jordan. So what I did on the next page is I solved the very same system up there using the Gauss-Jordan. And you could practice this. Remember, you're going to have some on the test that you actually have to tell me what the row operations are and then give me the resulting matrix. And you do need to know how to do this again. You gotta. So, if you'll notice, the 0, 2, negative 2, and 1 happens to be the very same values that I've got over here. So, use matrix inverses to solve this system of equations. So, put this in matrix A, your coefficient matrix, and remember to put this one in C. So, let's see if we can go do this real quick. I'm going to go edit A. It's going to be a 3 by 3. So I've got 4, negative 5, negative 6, 1, negative 2, negative 5, 2, negative 1, 0. Okay, so let me quit that. Or go get my next matrix. I want to go over edit. I want to do number 3. And 3 is going to be a 3 by 1. So negative 4, negative 12, 7. Second quit. And since I have A inverse times C, that's what I'm saying it should be. Let's see what I've got here. I prefer this right here, but this is showing you the variable matrix. Okay, and actually we solved this one sometime back using, I believe, the Gauss-Jordan. And that's it for this chapter. Thank you.